Hello everybody. We are going to talk about the art of proof. Hey, it is an art. It's like picking up seeing oil paintings and going, might as well try that. And you pick up the brush and you kind of dab the paint and it just does not come out looking like anything. And you kind of know where you're going to go, but you have to practice the basics. And the basics here are practicing on problems that hopefully you feel pretty good about algebraically. So today and tomorrow, that's how important this is. We're going to be kind of getting used to these ideas, these reasons, these justifications, and so forth. So let's look at our first slide. When I talk about the reasons bank, this is kind of the justifications, and this is what I was talking about yesterday. Having these notes and kind of having an idea that you can go and look, let's see, why can I do that? Was it this? Was it this? Maybe it's that. And that's going to give you that peace of mind that you have these. So you can print this out, of course. I'll have this on Blackboard, Google Classroom. So let's look at our first example. Nothing too difficult. It's just one of those angle addition problems. And here's all the steps. It's like, wait a minute, Mr. Sayers, the math is already done for us. Yeah, this is where we used to be. And I thought, we get good at this. Now we use that to show proof. All right. How do we justify or give the reason that we can do this statement? Well, why in the world can we say measure of angle AOB equals 20? Because it's told. We're told that, so we just write given. And usually the given is restated first, but sometimes people get all fancy and maybe write this one way later when they need it. But in this case, luckily, that is our second given, so that's the reason we can tell the world that we can make these bold statements. All right. Now this is a pretty bold statement. I would say the measure of that angle plus the measure of that angle equals the measure of that angle. Sorry about that. We'll all make little mistakes, and it'd be better to get that correct. AOB is little, BOC is little, and AOC is big. That is called the angle addition postulate. And I'll just show you real quick. That one's right here. So they're there for you. They don't mean anything unless you've paid attention. So you can definitely write notes right here or a picture, anything that might help you. All right. So far the world is okay with us. We have justified that statement. We've justified that statement. And you know what? We've justified that statement because the world has to understand there is an angle addition postulate that allows us to say that. All right. Now, what bold move did we do to use the statements above us to have the audacity to write that? Well, we know that AOB is equal to 20. We know that BOC is equal to 22. So all we're doing is substituting. You can put POE there, property of equality, because we are dealing with equal signs. But usually substitution is kind of a general, and people are okay with just substitution. And then this amazing thing happens, and the world wants to know, how in the world would you ever be able to say from here to here? That is called the addition property of equality. We are finished. We have arrived at where we're going. So we say to the world that we are finished. BAM's my favorite. QED if you want to get Latin on me, or the good old little teeny black box. All right, let's try another one. Problem 2. Without all the statements and all that, let's just look at the problem itself. Here's our given. We know that xy is equal to this length, so we're given this. And yz, we're given this. And we're told that the whole thing is 26. So at this stage, maybe you should go, well, I know how I'd solve it, but then right here you go, well, shoot, the problem's already solved. Well, the world wants to know that you can show those and justify those steps. So that's the shift that you have to give yourself, that you're really, the problem's done for you, or you know what the answer is going to be. How about that? You just need to get there. All right. How in the world can I say this first statement? Well, that is given. And the world relaxes. They go, okay, yeah, I'm good. And then you say yz equals 2x, and they get a little tense again, but then you tell them to relax because that was given. And that's also given. Sometimes these are all lumped into one statement, and so you have to write given once. That's fine too. Here they're broken up into 3. That's fine. It makes it look like it's a longer proof. Ooh, yeah. All right. What in the world, why can we say this little piece plus this little piece equals this big piece? Well, that is the segment addition postulate. I lose some students sometimes when they just want to say, common sense, Mr. Sayers. And I get that, but common sense doesn't work later on when you think, hey, everybody can see what's happening here, and it's not so clear. So if you use these accepted rules and postulates and theorems, life's pretty good. All right, so this is a pretty big step. Do they have anything to do with each other? Yeah, it just goes to show you that we're gonna use these 3 and kind of put these 2 together. So I think I can justify that, saying that we're just substituting. Yeah, substitution. All right, what did we do from to justify this next step? The world's a little nervous. It doesn't look the same. We've done something. Is it okay? And what we've done is we have distributed. So distribution property of equality. Sometimes you just say distribution property. I think distribution property of equality is better. Something crazy happened here. It looks like the 3 and the 2x. Yep. So that's combine like terms or simplify. And up on the reasons chart, I wrote simplify, and then I put in parentheses combine like terms. To go from here to here, it looks like a subtraction. Of what, Mr. Sayers? Looks like we subtracted 6 from both sides. Subtraction problem. Awesome. And finally, this crazy thing called division. Property of equality. Because what I did is I divided both sides by 5 to get this. Ladies and gentlemen, we are finished. We have done what we needed to do. We've gotten to x equals 4, and so we are done. So maybe this time I do something like BAM! That was a good one. Obviously, a proof is going to require you to do these steps, not me. We're just holding your hand. So the idea of proof and the idea of these steps, I hope you're paying attention, like, would I be able to pull these steps off? And that's going to be a fun little challenge for you. All right. So this is what tonight's homework is going to kind of look like. We're going to give you some basic, some givens and some proofs and 4 problems. Here's the deal. Some of you will only get this far on some of them, just because they're gripped. But this is actually a good start. It means you know that you draw this T-chart, you write statements, you write reasons or justifications, and you at least give me the first start and write given. Whether or not you can kind of see how to connect some statements to get to PR equals QS, you know, that's kind of up to you. I would say when I'm doing a proof, I know that this is equal to this. Great. And what I'm trying to show is that length is equal to that length. A couple things come to mind here is like, do you believe it? Do you believe that when those two, do they look equal? That's a good help. That's a good start. So maybe you start with something. Maybe you say, hey, PQ plus QR is equal to PR. Why do I say that? Because little plus little equals big. And you're like, God, I don't know if that's going to help me. And maybe right now I don't do my reasons. Maybe I'm just kind of working this out. And maybe I make a mistake, I erase something. But then well, if I say that, maybe I could say QR plus RS is equal to QS. Okay, and maybe, you know, and then maybe there's some way to substitute or make a connection and get to PR equals QS. Now, if you're sitting there like, well, finish it. I'm not going to finish this one because that really, I want you to know that that's the art of proof, is to go from the given to the prove and know the little tricks of the trade that you know that you could justify, and you only get better by trying these. Okay, only get better with trying these. All right, I will tell you that the homework is on, yep, that should be it. All right, I don't know what happened. There we go. What you're going to do is go to classwork. You're going to go to Thursday, and there is a document with 4 problems. That's it. No bookwork today. If you can, print them out, great. If not, that's fine. But what I'll be looking for is like on number 1, you have this, and hopefully you have that first statement. I'll just give you the justification for the first statement on all of them. It's probably something that looks like that. Hey, start it, give it a shot. I will certainly print out some hints for you. All right, you guys take care.